here we go, volume scale factor. Now this is all to do with the fact that when you increase the dimensions of a three-dimensional object by a scale factor of, for example, 2, if you make it twice as tall, twice as wide, twice as deep, it's not twice as large inside, it can hold 8 times as much, and that's because it's got larger in all 3 dimensions. So we need to find 2 things when it comes to looking at volume scale factors. We need to find the length scale factor, and then we use that to find the volume scale factor, and then that can help us find the new volume without having to do the new calculation. So there's no way of working on this, so I've got some square paper. So we have a pair of boxes, 2 cereal boxes, apparently 5. Oh, wheat shavings, how lovely. Anyway, that's completely beside the point. So first of all, we always look at the length scale factor. And to find the length scale factor, we divide the longer length by the shorter length. I must stress here, I'm not talking about a length on the long, so this and that. I'm talking about the corresponding length on both shapes. So in this one, I'm using the height of each. So the longer height divided by the shorter height. So I'm going to do 40 divided by 25. I'm going to use a calculator to do that. This will almost always be a calculator topic. And it gives me as a fraction first. I'm going to convert it into a decimal in this case because it's a nice terminating decimal, 1.6. That's my length scale factor. The large cereal box is 1.6 times as tall as the small cereal box. But the volume scale factor is 1.6 times deeper, 1.6 times taller, and 1.6 times wider. So it's 1.6 times bigger in every direction. Just for illustration, I'll write it out like that, but we know that if we've got something multiplied by itself 3 times, it's the same as saying cubed. And if you think about the units of volume, they are usually centimetre cubed or metres cubed or millimetres cubed, so the cube makes sense. In the same way for area, it's squared. Now we've got our volume scale factor, we can find the large volume it's going to be the small volume multiplied by the volume scale factor. Okay, the small volume, the small weight in this case, is 500. Remember, volume is related to mass, 500 grams. I'm going to multiply that by the volume scale factor, which is 1.6 cubed. You notice how I haven't really worked it out? Because it hasn't asked me to. If it did, I would be able to tell you that it is 4.096, but I don't need to know that in this question. I just want to know the new weight, so I'm going to do 500 and multiply that. There we go, 500 multiplied by 1.6 cubed. It's probably confused by the shadows that are going across. 2048. Hey, is that game? Never play that game. It is so addictive. 2048, 2048 grams. So that's what I'm writing here, 2048 grams. Okay, looking at the second page. These two cups are similar in space. The larger one can hold 2.6 litres. How much can the smaller one hold? So first of all, we do exactly what we did before. We find the length scale factor. And the length scale factor is the larger measurement, the larger height, 42, divided by the smaller hat, 21. 42 divided by 21 is 2 exactly, nice and easy, which means that the length scale factor is 2 and the volume scale factor is 2 cubed. Now we can actually work that one out because we know that 2 cubed is 8. So we may as well write that one down because it's not a decimal. We like integer scale factors, they're nice. Now are we trying to find a smaller volume? We're trying to find a smaller volume this time. And when we're trying to find a smaller volume, we do the larger volume, and instead of multiplying by the scale factor, we divide by the scale factor. The volume scale factor, remember, because we're looking at volumes. So I'm going to do 2.6 divided by 8. Again, that's going on my calculator. Don't want to decimal, please. 0.325 litres. It wants it in millilitres, so remember, 1 litre is 1,000 millilitres. So 0.325 is no thousands, 325 millilitres. Okay, sorted. Now over the page, we are told the volumes. We are asked to find the lengths. Similar method to before, but we just need to think about what we've got. So can we work out the length scale factor? Well, no, we can't because we don't know 2 lengths. But can we work out the volume scale factor? Yes, because we know 2 volumes. The big volume is 729, the small volume is 27. If you're very good with your powers of 9, you might be able to do that in your head. I might be able to if it was 9 o'clock on a Sunday evening, but the answer is 27. So the volume scale factor is 27. Now remember, to get the volume scale factor, we cubed the length scale factor. So to go back the other way, if we want to find the length scale factor, we need to find the cube root of the volume scale factor. So we need to find the cube root of 27. That is one that you should know. Cube root of 27 is 3. You should know your cube numbers for 1, 2, 3, 4, 5 and 10, if not 6, 7, 8 and 9. So this length scale factor is 3. That's not what it's asking us. It's asking how tall is the big one. Well, to find the big length, we know this from doing similarity stuff. We do the small height and we multiply it by the length scale factor. So the small height is 6.1. Multiply that by 3. Don't need a calculator for that one. 18.3. Okay, sorted. Now the next one is going from big to small again. So we're going to use the same kind of method as we just did in that question with the what were they? Oh, Russian dolls. With the Russian dolls. So we've got to find the, first of all, we don't know the length, but we know the volumes. We know both volumes. In order to find the scale factor, we need to know the same piece of information about each shape, whether that be the height for both shapes, the width for both shapes, the area if they're both 2D shapes, or we need to know the volume if they're both solid shapes. So the volume scale factor is the big volume divided by the small volume, which is 550 divided by 500. So they're quite close, aren't they? And we can see that's going to be 1.1. Just checking that because, like I said, it's 9 o'clock on it. Yes, that's correct. Oh, goodness. So we don't want the length. We want to find out a missing length though. So we need the length scale factor. So the length scale factor is going to be the cube root of the volume scale factor, which means we're looking for the cube root of 1.1. This is not one you're expected to do in your head. In fact, I'm not even going to work it out because it's going to be a very long decimal. So, to find the missing length, are we finding the small length or the large length? We're finding the smaller length, which is going to be the big length divided by the length scale factor. Really important that we use the length scale factor here because we're looking at lengths. Big length is 16, and we're going to divide that by the cube root of 1.1. If you want to write the decimal down, then go for it. But the decimal, in this particular case, is 1.0322801115, and that will be rounded. So that's why I didn't write it down. But we don't want to. We want 16 divided by that, which gives me 15.99. So it's not much smaller at all. But if you think about it, that makes sense. It's only got 50 millilitres more in it. It's only got 10% more in it. What does it want? To one decimal place. So that's going to be 15.5. So it's actually only half a centimetre smaller. Tiny. Tiny difference there. Hopefully that helps.